So what we're going to do today is just practice a few precipitation reaction chemical equations, basically how to write them. So you can see in the first example here, we've given the answer to you. This is just supposed to be an example, so you get the idea of what you need to do for the next few questions. Okay, so in the first example, and just remember our basic formula for precipitation reactions was this. Okay, this was what we covered in 4.5. That this is the basic kind of template or formula that we use. Okay, AB, which is an aqueous solution there, plus CD, which is again aqueous in state, gives us AD, which is, does anyone know what we called AD? It starts with the letter P, plus CB, which is again another aqueous state matter there, or it's just something that's been dissolved in solution. Okay, what do we call AD, guys? The one in the one that's got the S in brackets. What do we call that? What is that substance called? It has a special name. Come on, we remember. It starts with the letter P. Precipitate. Excellent. Good work. Okay, so precipitate is basically what this thing is called. It's basically, remember last time I said that whatever substance, if you mix two substances together and there's some kind of cloudiness that builds up in that test tube, or there's some kind of gloopy kind of jelly-like texture or substance that forms in there, that becomes an undissolvable substance. Okay, so any undissolvable or insoluble substance that is left behind in the test tube or the beaker after two aqueous solutions have combined is known as the precipitate. Okay, and there are a few characteristics of the precipitate that we talked about. Number one, that the precipitate is always solid, so it's always got a solid state of matter, which is why we put the S in the brackets there. Okay, and number two, that our precipitate, our substances that form precipitates are shown in the solubility table right in the middle column, the second column under the heading insoluble. So whenever it says insoluble, okay, everything under that column is going to form a precipitate there. Okay, whereas everything in that first column of our solubility table will not form a precipitate. Okay, so looking at this example now, when we talk about silver nitrate and sodium hydroxide, so this is the question literally. We've given you the two reactants, or the two things that will be to the left side of the arrow, the two substances there. And they're both aqueous in nature. Okay, we know this because as per our formula, it's always two aqueous substances that combine together. Okay, the first one is called silver nitrate and the second one is sodium hydroxide. Okay, so first we've asked you to write a worded equation. What does that mean? That means that you're literally just writing in words. You're not putting any chemical symbols here, just the words alone. So what you're going to write now is silver nitrate and sodium hydroxide. That's already given to you. Now you're going to predict this. This was not given to you. This is something we had to figure out for ourselves. So when we're at silver nitrate plus sodium hydroxide, we've got our A. Sorry, let me just rub all of the scribbles out. We've got our A, that is silver. We've got our B, that is nitrate. We've got our C, that's sodium. And we've got our D, that's hydroxide, okay? According to our formula now, the positive ion associated with the element here that's A, which is silver, gets attracted to the negative, which is hydroxide. Remember, hydroxide has a OH minus charge, and silver is Ag plus, yeah? So basically, they basically get attracted to one another, and there's a kind of swapping that occurs. Swapping in the sense that we call it double displacement. There's a swapping of the substrates here. So silver hydroxide, as per our formula, whatever precipitate will form will be A and D, and they'll combine together. In our case, A is silver and D is hydroxide. So that's how we came up with silver hydroxide as the first product that's formed, plus CB. So now we look back to our classification here. C was sodium, B was nitrate, sodium nitrate. Okay, that's the idea. So all we're doing is we're matching, first we're labeling what we've got, and then we're figuring out the name of the products that are going to be formed. So the precipitate and then the other aqueous solutions that's going to be formed by looking at and by matching it up to that formula that we've got there. Now guys, can anyone tell me, and sorry, there's a lot of writing on this page, so I have to, let me zoom, sorry. Let me zoom in, sorry, so it's a bit clearer. Okay, so hopefully that's a little clearer now. Okay, so guys, in our products here, just to recap, can anyone tell me what is the name of the precipitate that is formed? Out of those two products, which one is the precipitate? If you know, just put it in the chat box. So I'll ask again, out of these two products, which one is the precipitate that's formed? What did we say about the precipitate, guys? Did we say the precipitate is a gaseous substance? Did we say it's an aqueous substance? Did we say it's a solid substance? What did we say? Which of the following best describes the precipitate? Is it solid? Is it aqueous? Or is it gaseous? Or is it liquid? Which one is it? Our precipitate is always solid, yeah? We know that because it's in our formula. So AD brackets S. So the precipitate is always a solid substance. Okay, so for that reason, we know that silver hydroxide in this case is our precipitate because of the positioning in which we've written that. Remember, AD comes first, at least according to our template here. And in our final equation, AD comes first as well. So this first product corresponds to this first product here. Okay, that's how we know that silver hydroxide is the precipitate in this situation. Okay, that's going to make a little more sense now when we look at the balanced chemical equation. So when we're looking at the balanced chemical equation, what we're really looking at here is we're just writing the chemical symbols for the worded equation that we wrote here. Okay, and again, this will require you to understand how those chemical formula are written, do any balance, do any swapping of charges if necessary, and make sure that you're writing it properly. Okay, so silver nitrate, silver is Ag plus specifically. Okay, and nitrate is NO3, and the charge on nitrate is minus. Now, when these two swap charges, because this is technically +1 and this is -1, they're not going to get any new subscripts there. It's just going to be Ag, NO3. Remember how we said that when it's got the same number, they just cancel each other out and equal to 0. So there's not going to be any new charges there. We're not going to have Ag2, for example. That's not going to happen. So that's why our formula for silver nitrate is Ag, NO3. Okay, and it's aqueous because according to our formula, the whatever substance is in the position AB there is going to be, aqueous. The next one is sodium hydroxide. So with sodium hydroxide, what we have is we've got sodium, we know it has a +1 charge again. Hydroxide is OH minus. Hydroxide is just one of our polyatomic ions. So we take that charge from the periodic table there. So that's the basic idea. So then this is going to be again NaOH. Okay. So no new subscripts there, that's just as it is. Again, it's aqueous because the same substance that's in the formula here, Cd, always takes an aqueous state of matter. So that's why that's aqueous. So when these two combine now, they produce, or the products that are formed are silver hydroxide, which we know is our precipitate there. We're just writing it in chemical formula. Okay, silver hydroxide. Again, silver hydroxide is AgOH minus. The reason being that Ag is a plus charge. OH has a -1 valency. When they swap, this is going to be AgOH. Okay, this is just the basic swapping of formulas that we looked at before. Okay, and the last one is sodium nitrate. So with sodium nitrate, again, it's the same thing. Na has a +1 charge and NO3 has a -1 charge. So because they've both got a charge of 1, either positive or -1, they kind of cancel each other out. Yeah, there's no new charges that come up here. So it's just going to be NaNO3. That's how we get NaNO3 here. Okay, and again, according to our formula, it needs to take on an aqueous state of matter. And so that is reflected here. And the same thing with the silver hydroxide, which was our precipitate. Precipitates always take a solid state of matter. Okay, being the first product, we see that reflected here as well. Okay, so that's basically our worded equation and balanced chemical. Guys, is there any confusion about this so far? What we've done so far in terms of this formula or in terms of how we apply this template or this formula to like a question like this. Just let me know if there's like any part of it that doesn't make sense or doesn't add up or is confusing or you don't understand where that came from. Just let me know, okay? Otherwise, I'm just going to assume we're all good and just keep going. Okay, so remember guys, worded equation is just using plain old words. There's no chemical formula here, okay? That's the idea. This is probably the easiest part for you to do. Now, can anyone tell me, how did we get the products in here? How did we get these products? Because they're not given to us in the question. So how did we come up with the products now? We used our formula. Okay, that's why I've given you the box here. Okay, we're just using the formulas. The first thing you're going to do for each of these questions, guys, step 1, label this A, B, C, D. These are your A, B, C, D. If you know your A, B, C, D of your whatever question you've got, whatever compounds you're dealing with, you can figure out what the products are going to be. Remember, that's why we said we have chemical equations and we have these specific formulas for chemical equations, because we can use this to predict what the products of a chemical reaction will be. In this case, we can predict what the products of this precipitation reaction will be between silver nitrate and sodium hydroxide. So if we've got A, B, C, D already, we know the first product is going to be the combination of A and D, silver hydroxide, silver hydroxide. And the second product is going to be the combination of C and B. So that's going to be sodium nitrate, Cb, and then sodium nitrate, which is Cb, okay? That's all we're doing. We're just applying whatever question we have to the formula that we have, okay? So that's the basic idea. All right, and we've already looked at the worded equation, full balance chemical equation. I just want to explain to you guys what the ionic equation is. We went through this in 4.5, but again, some of you didn't do this question in the worksheet as well. With the ionic equation, all you're really doing is you're looking at what the precipitate is, because remember, the ionic equation is always for the precipitate, okay? It's always for the precipitate there. Precipitate. Okay. And with the precipitate now, we know our precipitate is a silver hydroxide, yeah? It's the only solid substance in our products from this chemical equation. And so it's also got Ad there. It reflects their precipitate. All right, so the ionic equation is literally you write your precipitate as it is. So take whatever precipitate you got there, bring it down here, and you work backwards. So you're working backwards now to figure out what were the two components that were required, or what were the two elements, or more specifically the ions that were required in order to make this precipitate or to form this precipitate. And when we say ionic equation, guys, what's an ion? Can anyone remember from chapter 3? How would we define an ion? Yeah, excellent. So an ion is either positively charged or negatively charged. For this reason, in an ionic equation, you have to include the charge, okay, of each ion that's involved. We know that in order to make silver hydroxide, we need 1 silver or 1 Ag, which is the chemical symbol for silver, and we need 1 hydroxide atom, okay? So we need 1 times silver and we need 1 times hydroxide, okay? 1 of each. How we're going to write that now is we just represent these atoms using the charge that's associated with them, or using not the actual elements themselves or the chemical symbols or the atoms, but using the ions. We know that silver tends to have a +1 charge, okay? And we know that hydroxide tends to have a -1 charge, okay, being a polyatomic ion. So you just write Ag +1 charge, brackets aqueous, OH -1 charge aqueous gives us the final precipitate, which is formed. And remember, the final precipitate in our equation never had charges attached to it. So obviously in your actual answer, you're not going to have any charges attached to it here. But when it's coming up or it's building up to become the precipitate, that's where the charges need to go. So in an ionic equation, there are charges to the left of the arrow, but there are no charges on the right of the arrow when you write the actual name of the precipitate there. Okay, any questions, guys, about the ionic equation, or how to write it, or how we go about doing it? I know we've usually in the past told you guys when we write chemical equations, you're not supposed to put charges in there. Ionic equation is probably the only exception for that we learn about this year, okay? In an ionic equation, you can use charges only for the elements to the left of the arrow, that is the reactants, that make up or that form together to combine and make the precipitate there, okay? Okay. Yes, so only for the ionic equation do we put charges. For any other chemical equation we ask you to write. For example, in this chemical equation, sorry, there's a lot of scribble. Get rid of all the scribbles. In this chemical equation that we asked you to write, you can see that there are no charges there. I don't write Ag plus there or NO3 minus. That's wrong. I don't write that there. If you get an ionic equation though, you can include the charges only for the reactants. That is only for the substances that are to the left of the arrow there, okay? All right, guys, the last thing, and this is the last part of the question, the sample question here. The last part of each sample question on this worksheet is to name and write the chemical formula of the spectator ions. Does anyone remember what the spectator ions are? Or why did we call them spectator ions? Does anyone remember? There's a specific reason. They just observe. Excellent. They just watch. Yeah, so in terms of our spectator ions, just like normal spectators at a sports match or at a show, these ions don't actually take part in the formation of the actual precipitate. They have no role to play in the formation of silver hydroxide, which is our precipitate in this question. Okay, so these are the ions that basically just sit back and just, you know, chill. They don't really do anything to form the precipitate there. The easiest way to figure out what your spectator ions are to basically go back to your question, go back to your chemical equation that you've written down, and just go to the reactant side. And all you're going to do is cross out the elements that were a part of the precipitate. So in our case, our precipitate is silver hydroxide. So we're crossing out the silver, because that's already been used to form the precipitate. We're crossing out the hydroxide because that's already been used in the hydroxide part of the precipitate there. And so all we've got now are sodium and nitrate. So automatically those two, 1, 2, become our spectator ions, okay? Anything that's not directly involved in the formation of that precipitate. You know what the precipitate is? It's the only product with the S symbol next to it, okay? It's the only product represented by AD. It's the only product that was insoluble, okay? Everything else was soluble, everything else dissolved. This precipitate was the insoluble substance that got left behind in the test tube or the beaker. In this case, it's silver hydroxide, okay? So if we cross out silver, cross out hydroxide, we've only got Na, sodium, and NO3 here, which is nitrate. And that's why we write sodium ion and nitrate ion are our spectator ions. They just sit back and observe. They're not involved in the formation of the precipitate. And then we write their chemical formula like this, just Na plus, okay, because we know sodium has a +1 charge being in group 1. NO3, nitrate, is actually a polyatomic ion. So you're going to refer back to your valency table for the charge if you don't know it already, okay? So that's the basic idea. And we know that NO3, if we look at our valency table, has a -1 charge there. Okay, so that's the basic idea. That's our spectator ions, okay? Okay, guys, before we go through the next question, are there any issues with any part of this? So either how to write the worded equation, full balance chemical equation, how to write the ionic equation, or how to write the spectator ions. Because guys, these are typical questions that come up in the test, they come up in the exam. So if you can't do them here in class, or you can't do them on your worksheet, you know, it's not going to come to you straight away when it comes to the exam. So that's why we need to clarify these, you know, while we're doing them. So just let me know. Otherwise, if you feel hesitant to ask me now, just ask me, like email me and let me know, okay? Because otherwise you are going to have some gaps in your knowledge there. All right, cool. So what we'll do is we'll go to the next example now. If I can just go back a little. In fact, what I'll do, so you guys can keep referring back to that formula as well. I'll just try to move this on to the next page and then see if I can put both of them on one page like that. Would that work? Oops. Okay, what I need to do is move that one further down. Okay, just in case those of you who haven't downloaded the worksheet. Why doesn't it stay? Okay, I think that should be all right. What I'll do is I'll just make the font a little bigger. Okay, so hopefully you guys can see this. So what I want everyone to do now is I want everyone to just do the same thing we did here, but now we're doing silver nitrate and potassium iodide. So the precipitation equation for these two elements, for these two substances or compounds here. Okay, so I'm going to give you guys about 5 minutes to try your best to do as much of this as possible. You don't have to complete every single bit there, but just as much as you can. So I'm just going to start the timer now. So 5 minutes starting now. And I think I'll also pause the recording while we work on this. Okay, so for this question so far, we went through the worded equation, we wrote the full balanced equation before, and now we figured out the ionic equation. So now all we really need to do is we need to write the names of the spectator ions. So what I'm going to do is I'm going to show you guys that tip again that I told you before. When you're figuring out what the spectator ions are, you're thinking about what are the ions that did not take part, the specific ions that did not take part in the formation of the precipitate. Okay, what does that mean? The precipitate is the undissolvable solid substance that's left behind. Look into my formula. Go, 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 go. Where is it? It's here. This is the only solid substance, okay? Whatever was not involved in the formation of this substance or this precipitate is a spectator ion. So I go back to my reactants, okay? These are my reactants. These are what I had in the beginning of the experiment that led to the products, okay? So this is what I'm looking at now. Silver iodide is my precipitate. Cross out silver, cross out iodide. Okay, my two spectator ions are thus the ones that are left over, which are potassium. Sorry, potassium ion, that's how I name it. Potassium ion. And then I've got my nitrate. Nitrate ion. Okay, that's how I name it in words. And then how I write it in chemical formula is simple. I just think about potassium. Potassium has a chemical symbol of K, and it's got a positive 1 charge. Okay, so it's plus because it's in group 1. And then nitrate is a polyatomic ion, and it's got a charge of negative. So the whole thing has a negative 1 charge. Okay, that's how I write it. So those are my two spectator ions. They're the ones that were not involved in the formation of the precipitate. So I crossed them out. Sorry, I crossed out the ones that were involved in the precipitate. So silver iodide, crossed out silver, crossed out iodide. Whatever was left behind on the left-hand side of the arrow or on the reactant side is nitrate and potassium. They automatically become my spectator ions. Okay, that's the basic idea there. Okay, guys, you need to know how to do this. That's why I'm trying to take a lot of time to do this properly with you guys, to explain it step by step. So I really want you guys to be able to do this, because if you can't, then it's going to be hard for you during the test. It's going to be hard during the exam as well. Okay, so make sure you understand this. If you don't understand it, please email me. Don't wait until the night before the test and start panicking when you don't know how to do it. Email me and I'm happy to write you a step-by-step explanation of how to do this, but you need to understand how to do it. Okay, so on that note, guys, we've gone through about 2 examples there. The first one was already given to you nicely typed up. Okay, not like the scribbles that I was doing now, but you can go back, rewatch the video when I upload the recording if you like, and try to make sure you understand each step that's involved and how we get to each of those steps. There are a few more questions here in this worksheet. Go through as many of them or as little as them as you want until you feel confident that you can do it. Okay, you don't have to do the whole worksheet if you don't want to, but I want everyone to submit this worksheet by 11:59 p.m. tonight, at least having completed 2 more examples. So you can go, for example, silver nitrate and sodium chloride, and then silver nitrate, potassium carbonate. At least 2 is the bare minimum. So I can know to some extent that, okay, you know some stuff or that you don't know anything at all. So we can work on this before the exam and before the test a little more. Okay, so this is your work for today. Complete 2 more, any 2 more precipitation reaction questions. Okay, it can be just the other 2 in the worksheet, or you can look through all of them and choose the one you want to do. It's up to you, but I want you to at least do 2 more. That's the bare minimum. If you can finish the whole booklet, oh my God, you would make me very, very happy if you did that. But I'm not trying to put too much stress and pressure on you right now. So if you can at least do 2 or 3, that would be more than enough. And you're going to upload that using due work. Okay, so that's your work for today, your homework for today. All right. And those of you who haven't submitted 4.5 worksheet, you need to also do that ASAP. Okay, I know most of you have, and good work for those of you who have, but some of you haven't submitted that yet. So I do need that to be submitted under due work. Okay, guys, if there's no other questions, I'm just going to stop the recording here.